I want to do a quick review of imaginary numbers. You do have a handout called Imaginary Numbers that has everything in it that I'm going to be talking about and more. But for those of you who like a verbal explanation of things, I'm going to explain some of these verbally as well. So first of all, a long time ago, there was a man, a mathematician named Cardano, who was attempting to solve a cubic equation, and he ran into a problem when he had to take the square root of a negative number. And there is no such thing in the real number system as the square root of a negative number because, as you know, for example, 1 squared equals 1 and negative 1 squared equals 1. So how in the world do you multiply a number by itself and have it equal negative 1? Well, there is no such number, so he made one up and he called it the imaginary unit and named it I. And he was mocked for many hundreds of years by other mathematicians who thought he had made up something that was totally worthless and imaginary. Imagine, of course, they all rolled over in their graves when they found out that without the imaginary numbers, electrical theory as we know it could not be done. So all the stuff that runs on electricity, we needed to know the math involving imaginary numbers to do that. So there's your little history lesson. Anyway, how do we handle the square root of 1? Well, there's two things you need to know. One is you need to know that the square root of negative 1 is I, and also that I squared then equals negative 1. If you know those two pieces of information, you can do just about anything you want to with imaginary numbers. For example, if I wanted to take the square root of negative 4, I could say that's the square root of negative 1 times the square root of 4, which is I times 2, or 2I. So the square root of negative 4 is 2I. I could say the square root of negative 59 is the square root of negative 1 times the square root of 59, so that's the square root of 59 times I. So if you take the square root of any negative number, it's the same as the square root of the positive number times I. Now if I want to, I also can name numbers that are both real and imaginary, and those are called complex numbers. Complex numbers would be, for example, and we usually use z to denote a complex number, 2 minus 3i. So this has a real part, the 2, and an imaginary part, the negative 3i. And combined together, we call that a complex number. All real numbers and all imaginary numbers are also complex numbers. I can graph a complex number, but I have to graph a complex number on a special plane called the complex plane, in which the x-axis represents the real number part of the complex number, and the y-axis represents the imaginary number part. So I go 2 in the real number direction and 3 in the imaginary number direction, and this is the point 2, the number 2 minus 3i. That point represents the number. I can also do some operations on complex numbers. The complex number, for example, I could multiply 2 minus 3i times 4 plus I. And if I multiply this out, I would say 2 times 4 is 8. 2 times I is 2i. Negative 3i times 4 is negative 12i. And negative 3i times I is negative 3i squared. So I can combine together the middle two terms, 8 minus 10i, and then negative 3i squared. Well, there's my little I squared. Whenever you see I squared, that's negative 1. So that's minus 3 times negative 1, which would become plus 3. So I have 8 minus 10i plus 3, or 11 minus 10i. So every time you see the negative an I squared, turn it into a negative 1. Let's see, anything else I need to tell you about that? That's pretty much it for the quick review of imaginary numbers. If you can also raise a number to a power, and I'll just have you look at that on the review worksheet. I think that will be sufficient to explain that. Well, maybe I'll give it a quick explanation. Since we have I is equal to I squared is equal to negative 1. We've already determined that. So what's I cubed? Well, I cubed is I times I squared. So it's going to be I times negative 1, which is negative I. Well, what's I to the fourth? Well, I to the fourth would be I to the third times I, or we could think of it as I squared times I squared. I squared times I squared would be negative 1 times negative 1, which is positive 1. Okay, so then what's I to the fifth? Well, I to the fifth is I to the 4th times I, which is 1 times I, which is I. And I to the 6th is we can think of that as I to the 4th times I squared, which is 1 times -1, which is -1. Do you see that we're starting to repeat ourselves? So here we have I, -1, negative I, 1. Here we have I, -1. If we multiply I to the 7th is going to be I to the 5th times I. That's going to be -1 times I, which is -I. So there we go again. It just repeats, it cycles. So all you have to do is look for some power that is a multiple of 4. So for example, if I have I to the 24th, that's going to just be 1 because that's I to the 4th to the 6th power, which is 1 to the 6th. If I have I to the 25th, it's going to be I to the 24th times I, which is 1 times I, or just I. So that's how you work with powers of I. There's also some other things, dividing and raising to a power and so forth, but we'll just leave that for later. Now, looking at the worksheet, well, that's just my quick review of imaginary numbers. So we'll save imaginary numbers in polar form for another little video. Just realize one thing. I wanted to show you something on the calculator too. So on the calculator, we can add a calculator page. You can do imaginary numbers on the calculator page as well, on the calculator. So we had that one, 2 plus 3i. I'm not sure if that's what I had. Let me see if I can find the problem that I actually used. Oh, 2 minus 3i times 4 plus I. So 2 minus 3i times 4 plus I. Now this is the way I would, if I'm typing along, I'm just using my I down here. You know what? That's not going to give me anything. If I push enter, it looks kind of like garbage. That's because I used the wrong I. The correct I that I want to use is in this little symbol. It's under my pi menu. So I want to do this again, and I'm going to say 2 minus 3, and then use the I from this symbol here. And notice that it's in bold print. So it's in bold print, then you know you've got the correct imaginary unit. And then grab this again. And now I push enter, and look, there's my 11 minus 10i. It does the correct computation. So there's a little something I just wanted to show you. Now I'll stop.